So there's three types of equations when we're talking about net and ionic and things like that. The first one is a non-ionic equation, This type of equation shows all reactants and products as if they didn't dissociate in the solution. And that's actually how we have been writing. Like when I taught you reactions in Science 10, this is the type of equation that you did. So say we take lead nitrate. This is actually what we did this morning. I mean, right now. This is what we did. We took lead nitrate, so lead 2. So Pb bracket NO3 bracket 2, aqueous. And potassium iodide aqueous. After it's balanced, there's a 2 in front of the potassium iodide. So these were two clear colorless solutions. When I put them together, I made a precipitate. That precipitate was lead 2 iodide. And it's a solid. And that was that bright yellow color. And then, what's left over? Well, it's a double replacement reaction, so it's like they switched their dating partners, and now I have potassium nitrate left over. So this type of reaction, this is how you did it in Science 10, yes? Okay. Now if we kind of put together our knowledge of dissociation and our knowledge of writing these equations, what we can make now is a total ionic equation. So what you've been learning to do with your dissociation, we're going to apply it here now. This type of equation is more accurate and shows all soluble reactants, and products dissociated into ions. Okay, so when we think about it, it's like, okay, if all these things, so your lead nitrate, okay, that you just wrote down, that write your seeds in, aqueous, write your seeds in. If it's aqueous, really we know that that's broken down into lead 2+ and nitrate, right? Because we just learned that. It's an ionic compound, so it breaks down. Okay, then this one also breaks down, it's aqueous. The solid though, doesn't break down. Okay, once it's solid, like as a product, that is a solid inside water, so it's not soluble, right? So then we just leave it as solid, and this one, potassium nitrate, will break down. So how do we write out a total ionic equation? Well, just as I said, that's Pb 2+ there, Pb 2+. Sorry, just the background there doesn't show it. Aqueous. Okay, so now I've broken it down, and there's my nitrate. Now, why, even before balancing, how would I know that I need to put a 2 in front of that nitrate? Right, because in the compound, there was 2 nitrates, right? Like, yeah, so there needs to be 2 nitrates represented. Okay, I also have now my other compound. I have my 2 potassium. Again, there's 2 potassium because in the original compound, there was 2 potassium. And 2 iodine. Okay, because remember, here, it had a 2 in front of it, and it was Ki, so I have 2 potassium and 2 iodide, okay? Yeah? Right. and then on the other end, and I'm just going to show this below because there's not enough space, but you can put like your arrow here, that's fine. So then I have on the product lead iodide solid, and you just leave it as solid. Because it's actually, that solid is in the water, and if it's solid in water, it's not soluble. Plus 2 potassium ions and 2 nitrate ions. Now, our reaction arrow, I want you almost to think about it like an equal sign, okay? That every ion that's on the reactant side needs to have the same amount on the other side, okay? So we see that. We have 2 lead ions, or 1 lead ion, 1 lead ion. 2 iodine, 2 iodine, okay? You see that? Now, just like in math, if the exact same thing is on both sides of the equal sign, what can you do? You can cancel it, right? So that's what we're going to do next. That's the third step, is we're going to cancel things called spectator ions. They are the ions that aren't involved in the actual chemical reaction. They're just there to be like, hey, I was here before, but I don't actually do anything useful, right? Okay? So when we look at it, this nitrate, I have it at the beginning and I have it at the end. It's the exact same thing at the beginning as in the end. So that's just a spectator, we call it. It's just looking around to see what's happening. But who is actually involved in the reaction? Because how did I know a chemical reaction occurred? What's evidence of chemical reactions? What did I say when it happened? What was evidence? The precipitate. What else? Can you see it in the video? Okay. Yellow color change, precipitate. Okay. The thing that is the yellow precipitate is the lead iodine. So we know that that is the chemical reaction. This isn't in a chemical reaction, really. It's not directly involved in making the new product that is different, right? Because a chemical reaction is making something brand new. There's nothing brand new about this and this. They're the exact same. So, this is our third one. Oops. Just gonna